Hey there guys, today I thought that I would go ahead and make a video on bond line drawing for organic chemistry. It's actually a pretty simple concept, but to define it, it's basically the way that organic chemists simplify their drawings for organic molecules. And since carbon is like the pinnacle element for organic compounds, what they do is in bond line drawings, they can, if I had color, that'd be nice. There we go. If, say we have a compound like this. Now, it might not actually look like anything to you right now if you don't know what bond line is, but actually there's 1, 2, 3, 4, 5 carbons here, and on each of these ends and junctions, there are hydrogens that come off of there. I will, for the sake of this video, just draw those out for you so you can see that. But at each end and each junction, there is a carbon, and if there are no other elements that are drawn in on the structure, then assume that there are hydrogens attached to there. See, just like that. Now, so how do you determine how many hydrogens? Well, you have to remember that carbon's valency is 4, so it's going to want to bond 4 times. So there is a carbon here. Let me switch to red just to show you. There is 1 carbon right here, and then it's bonded to this carbon up here. And so since it likes to bond 4 times, this end carbon here, it's bonded to this carbon here with a single bond. And then carbon has 4 valence electrons, so it's got 3 more it can share with hydrogen. And since its valency is 4, it bonds to 3 hydrogens, and then there you go, it's very happy. It's got its 4 bonds, it's got no lone pairs, it's got no charge associated with it, so it is happy. And same here with these carbons. Here, how this is a junction between these 2 lines. There's a carbon here, 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 and again here on the end. And since this carbon is bound to this one and this one as well with another single bond, this carbon has 2 hydrogens that are attached to it. And that is the simple structure. Now, if we wanted to, let's say, have, oops, that's not what I really wanted to do. If we wanted to draw in double bonds, then that's also pretty simple too. Same type of thing. You've got another structure like this. If you want to have a double bond in there, all you got to do is just draw another line. There you go. And now, since this carbon, let me go back to the red, this carbon is doubly bound to this carbon. Now there will only be 1 hydrogen coming off of each of these, because remember, carbon only bonds 4 times. And we can't break the octet rule where every element is only allowed to have 8 electrons around it. So this carbon is bound here. It's got a double bond here to this carbon. Another bond up there. So there you go. There's the 4 bonds. And sometimes you'll even find problems where you might have a carbon ring that looks like this. And sometimes it's often that you'll find that there are double bonds in here. Now there's a special rule for these rings where, well, and even in these too, you cannot have double bonds right next to each other. So like if I was going to add another double bond, it'd have to be over here. And same here, like see how there's no double bond here between these two carbons? They can't have two of them right next to each other. So, but they can move around. So you can move these electrons around almost in like a circle. So they kind of like trade positions almost. And if you redraw that, now double bonds look like that, and you're still fine. And so one way that you can represent that those bonds can move around is it sometimes is notated with a circle there in the center. That just shows that these double bonds can just move around in a circular kind of formation around this whole thing. Now these arrows show the movement of the electrons in what is called resonance structures, and I'll talk about that in another video because that's a whole different story. But yeah, this is bond line. Remember, okay, points, ends, and junctions have one carbon. And if we want to have another molecule in there, let's say we've got an amine group, so we've got a nitrogen in there, all you'd have to do is draw it in. So it's connected. There we go. One blue, nitrogen, go. Draw it in like that. And then, you know, you'd have to add your lone pairs and all that stuff. You don't necessarily need to have lone pairs. You know, it all depends on grading and whatnot. But if you're unsure, just assume that you should put lone pairs in just to be safe. But normally the lone pairs don't show up in the bond line. One thing that they will do to notify you that perhaps there is a element that has a charge or like an unusual amount of either protons or electrons, meaning there is like the electrons that would normally be on that atom are either on a bond or on another atom, which happens a lot in resonance structures, then they'll depict that. They'll either put positive charge where there is one or a negative charge, just like that. So those are all the kind of notations that will show up in bond line structure, and I hope that helped you guys out, and subscribe if this was helpful, and look for more chemistry tutorial videos. Thanks for watching.